start with equivalent fractions. Okay, pecahan setara. Okay, why is equivalent fractions it's one of the most important concepts in teaching fractions, because so this is the foundation to converting fractions to decimals and percents. If students don't know how to convert fractions to equivalent fractions, then it is difficult for them to convert it to decimals and percents. Okay, so in order to be able to convert fractions to decimals and percents, they must be able to first convert it into equivalent fractions. Okay, so the second reason why students should learn equivalent fractions is it is extremely useful to compare fractions. Okay, all algorithms for comparing fractions depend on equivalent fractions. Third reason is it is the prerequisite knowledge for addition and subtraction of fractions with different denominators. Okay, so when students go on to learn operations involving fractions such as addition and subtraction, they need to have mastered equivalent fractions. Okay, if they haven't, then they will have problems doing operations of fractions. And finally, equivalent fractions are used for simplifying fractions. Okay, so for all these reasons, students must be taught to master equivalent fractions. Okay, so we're going to see how we can teach equivalent fractions conceptually. Okay, so here I have this thing here. What is this called? What is this thing called here? Anyone? Can you see clearly? Okay. What is it called? Fraction tiles. Yes, you can call it fraction tiles or fraction wall. Okay. So say we want to find the equivalent fractions for 1/3. Okay, 1/3 or 1/3. So what you can do, sometimes we have this fraction wall as a concrete material, or we can also have this as a chart in front of the classroom. Okay, you can have a big chart in front of the classroom. So if you wanted to find the equivalent fractions for 1/3, you just need to put a long ruler there. Okay, so when you put the ruler there, the student can look for fractions that are the same size as 1/3. So here we can see that 1/3 is equivalent to 2/6. Okay, exactly two parts here, 2/6 and 4/10. Okay, so here we only have three: 1/3, 2/6, and 4/10. Okay, so we have 1/3, 2/6, and we have 4/10. 4/12. Sorry, 4/12. Okay. Okay, so we can see that all these pieces are exactly equal size. Okay, so from here, we can help the student to say that 1/3 is equivalent to 2/6, and 1/3 is also equivalent to 4/12. 2/6 is also equivalent to 4/12. Okay, so as you do this repeatedly with other fractions, then students will be able to form connections. It is from here that we develop the algorithm for equivalent fractions. Okay, so don't rush straight into the algorithm and teach them how to calculate using symbols abstraction method. Okay, so first we teach them for conceptual understanding. They need to see clearly why this is equivalent, what we mean by equivalent fractions. Okay, so this is using fraction wall or fraction tiles to teach equivalent fractions. Okay, so there are many other ways that we can teach equivalent fractions. Okay, the other manipulative that we can use to teach equivalent fractions are paper folding. These are actually very nice. Okay, so all you need to have is paper strips like this. Okay, you as a teacher, you can prepare this kind of paper strips and you can give it to the students, blank paper strips. Okay, for them to fold. You can give them blank paper strips for them to fold. If you're dealing with fractions with with an even number denominator, they can fold easily. But if the denominator is an odd number, that's a bit difficult to fold. So you prepare the lines for them, okay? So let's say we want to find equivalent fractions for 1/2. Okay, so we have this is 1/2 here. Okay, so we give them paper strips. Okay, so we use another paper strip. Okay, exactly the same size and length. We divide it into 2 and then divide it into 4, open it up, draw the lines. Okay, so we want them to find equivalent fractions for 1/2. So we need to identify 1/2 first. Okay, so this is 1/2. We shade this 1/2. So now we have the second strip here that is divided into 4 equal parts. We also want to shade the size that is exactly equivalent to 1/2. Okay, so the shaded area is exactly the same. Then we ask them to take another strip of paper, same size, divide it 4 times. 1, 2, 3, 4. Okay, open it out, draw the lines. So you have 8 parts here. So shade exactly the same size as the above. Okay. Then you can go on, okay? You give them another strip, ask them to divide it into 16 parts. This is quite easily done because this is an even number denominator, okay? Then ask them to shade the area, same size, okay? So now you have 4 fraction strips here. They all have the same shaded area. So the fraction for the first strip is 1/2. You can see that this is 1/2, okay? Right, or halves, okay? And here we have 1, 2, 3, 4 parts. So each part is 1/4, 1/4. Here, each part is 1/8. Okay, and here each part is 1/16. Okay, so we can see that 1/2 is equivalent of 2/4, and it's also equivalent to 4/8, and it's also equivalent to 8/16. Okay, so 1/2 is equivalent to 2/4, equivalent to 4/8, equivalent to 8/16. Okay, so this is because all the strips have the same area size. Okay, so from here students can develop the algorithm for equivalent fractions. Okay, so we need to show them like this so that they can understand conceptually and they don't just memorize how to find equivalent fractions. Okay, so once they understand, they remember for life. Okay, usually. So we have seen 2 different manipulatives to teach equivalent fractions. That is your fraction strips and fraction wall. This either you can call it fraction strips or paper folding method. Okay, so that is for equivalent fractions. The next concept that we want to look at is comparisons of fractions. Okay, that means we want to compare fractions. When we teach comparison, first we teach them to compare 2 fractions, only 2 fractions, and then they have to compare more fractions and learn to order the fractions. Okay, so we're going to start with 2 fractions of the same denominator. Okay, for example, we have say you have 1/8 and 3/8. Okay, you have 1/8 and 3/8, which is bigger. So we show them 1/8. When you're dealing with fraction strips or fraction tiles, you must always show them the 1. Okay, so we have 1/8 and we have 3/8. Okay. Okay, 1/8 and 3/8. Okay, so you can see here that the denominator is the number at the bottom. Okay, the denominator is the same. Okay, so we can see clearly here that 3/8 is larger than 1/8. Okay, so 3/8 is greater than 1/8. We can see clearly that 3/8 is greater than 1/8. So if so from here, what can we generalize? What is the rule that we can generalize from here? Anyone? So anytime you compare fractions with same denominator, what can you say? What can you tell the child?
Equivalent.
What can you tell? The
larger the numerator, the larger the magnitude.
Yes, correct. Okay, so if the denominator is the same, the greater the numerator, the greater the fraction, the magnitude of the fraction. Okay, yes, when we compare fractions, we are actually looking at the size of the fraction. The size of the fraction, we say it is the magnitude of the fraction. Okay, so when we want to compare the magnitudes of these two fractions, okay, when we do this activity over and over again, students themselves come up with the rule that the greater the numerator, the larger the fraction, if the denominator is the same. Okay, so this is how you have to teach comparisons level by level. Okay, so the first level is same denominator. Second level is same numerator. Okay, an example of same numerator will be which is larger, 2 over 3 and 2 over 7. Okay, we also sometimes have problem when we see like this. Okay, 2 over 3 and 2 over 7, which is larger. Okay, so let's represent 2 over 3 and 2 over 7. So I have 2 over 3 here and 2 over 7. I don't have 2 over 7, so I have to change this. So maybe I'll go with the 2 over 10, okay? So I need tens, tens, 2 over tens. Okay? So from here, students can see that 2 over 3 is greater than 2 over 10, okay? So maybe we do another example, okay? 3/5 and 3/8. Okay? 3/5 and 3/8. Which is greater? 3/5 and 3/8, huh? Okay, so what can you summarize from here? What can you generalize from here? 3/5 and 3/8, 3/5 is greater. 2/3 and 2/10. So what can you generalize?
The less dominator, the larger the fraction.
Again?
The less number of dominator, the larger the fraction.
Okay, correct. That means the smaller the the smaller the denominator, the greater the fraction if the numerator is the same, correct? Why? Because if the denominator is smaller, it means
the parts are bigger.
yeah, the parts are bigger, okay? So you see, when you compare like this, 2 over 3 and 2 over 10, okay? So we know that 2 over 3 is greater than 2 over 10. And when you compare 2 over 5 and, 3 over 5 and 3 over 8, we know that 3 over 5 is greater than 3 over 8. If you want to teach this just using an algorithm or just trying to tell them, explain to them, it's very difficult, okay? So we need to show them using concrete materials like this. So as we do a lot of practice, students themselves will realize, okay? Students themselves will come up with a rule. Okay, so that is the reason we need to use this kind of manipulatives. So the next step, first, so just now earlier we compared fractions with same denominator. Now we have compared fractions with same numerator. Okay, so the last step would be to compare fractions with unlike numerators and denominators, which means the numerator and the denominators are not the same. Okay, for example, 3 over 4 and 5 over 6. You tell me which is bigger immediately without calculating. Can you do that without calculating?
3/4.
3 or 4? Okay. It is a little bit difficult to do that. Huh? If you don't calculate, it's a bit difficult for us also to compare, okay? So we must develop strategies to teach the children how to compare, okay? So we have 3 over 4 here, okay? 3 parts out of 4. And we have 5 parts out of 6. Six, huh? 5 parts out of 6, okay? So 3 over 4. So now which is bigger? Is it 3 over 4 or 5 over 6?
5/6.
Yeah, so we can see that, you see, both of them are 1 part away from, see, both of them are 1 part away from 1, correct? They just need 1 more part to reach 1. Both also need just 1 more part to reach 1, okay? But because 5 over 6, the denominator is greater, which means that the parts are smaller. That means it is a smaller part away from 1 compared to fourths. Fourths, the part that is away from 1 is bigger than the 6 fraction, okay? So for 3/4 and 5/6, so 5/6 is bigger, okay? So it is quite difficult for students to just compare. If you can use equivalent fractions and teach them how to compare, but when you give them more than 2 fractions, they won't be able to compare. They will have a problem, okay? Unless they can understand conceptually why 5/6 is bigger than 3/4. So we use manipulatives to teach them conceptually to compare fractions, okay? So supposing you have done this, supposing you have, we have a set of fractions, okay? Supposing we have a set of fractions like this, and we wanted to compare and order them, okay? So now we want to compare and order these fractions. We don't know which is the smallest here, so initially when we start teaching, we have to start teaching using concrete materials like this. We set out all the fractions, okay? So the first fraction is 4/5. So let's put 4/5 here. 1, 2, 3/4. Okay, 4/5. And then we have 1/3. 1/3. Okay. 1/3, 5/8. 5/8. And then we have 1/2. 1/2 and 4/10. Okay. 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 So now that we have set out all the fractions, we want to write down here which is the biggest. So what we can do is we can rearrange the fractions, okay? We ask them to rearrange from the largest to the smallest, okay? So now we have rearranged the fractions. So now we can write down our fractions from the smallest to the bigger. So this will be 1/3, 4/10, 1/2, 5/8, and 4/5. And 4/5. Okay, so this is how we teach them to order fractions using the fraction tile or the fraction wall. Okay, this is one very good method. After some time, they will get the hang of it. After this, we can use other more sophisticated strategies like mathematical reasoning. Okay, reasoning is a very good way to teach them to order this very, very fast. Okay. Okay, so okay, now we're moving on to improper fractions. I will show you other ways of doing this later, okay? But this, I'm just going to do the concrete materials first, okay? So now we want to do improper fractions. Okay. You know that improper fractions are fractions that are greater than 1. Okay. So supposing we had a fraction 7 over 3. Okay. What does 7 over 3 mean to us? One third. These are thirds, right? Okay. See, I have this here. Okay. So 3 parts of this equals to 1 whole. Okay, so these are 1/3. Okay, so 7 over 3 is 1 over 3, 2 over 3, 3 over 3, 4 over 3, 5 over 3. Okay, we have to change it to 5 over 3. I don't have enough pieces. 1, 2, 3, 4, 5. Okay, 5 over 3. This is 5 over 3. Okay, this is what we mean by improper fraction. When we want to teach children what does it mean, okay, this is how we teach them. Okay, take the parts, show it to them. That means they will understand that the base fraction is 1/3. 5 over 3, the base fraction is 1/3. If you have say if you have 9/6 or 9 over 6, that means the base fraction is 6, 1/6. Okay, so if you have 9 over 6, it will be 1 over 6, 2 over 6, 3 over 6, 3 over 6, 4 over 6, 5 over 6, 7 over 6, 8 over 6, and 9 over 6. This is what we mean by 9/6. Okay, students need to understand that. Okay, so when we say they need to know the difference between improper fractions and mixed numbers. If we say, okay, this is 5 over 3. Okay, if we say, how do you represent 2 and 1/3? That's a mixed number, 2 and 1/3. Okay, so because 2 and 1/3, it consists of one whole. Okay, there's a whole number that 2, and we have a fraction 1/3. So we represent it using 2 wholes, 1, 2, 2 and 1/3. Okay, so that is 2 and 1/3. If you want to show 1 and 2/3, okay, it's a mixed number, 1 and 2/3. We can even show it like this. This is 1 and this is 1/3, 2/3. So this is 1 and 2/3. So for mixed numbers, we show it like this, 1 and 2/3. Okay, so if you want to show improper fractions, 5 over 3, which is exactly the same value, 5 over 3, then we have to show it like this, 1, 2, 3, 4, and 5. Okay, we cannot show it like this. We have to show it like this. So this is the difference between improper fractions and fractions. Okay, so how do we convert improper fractions to mixed numbers? Supposing you have an improper fraction 5 over 2. Okay, that means 5 halves. Or 5 over 3, okay? 5 over 3. If you had an improper fraction 5 over 3, 1, 2, 3, 4, 5. Okay, so this is a 5 over 3. It's an improper fraction. And you want to convert this into mixed numbers. So what you have to do is join the parts until they become a whole. Okay, so this is one whole already. Then we take these two parts and we put together. So now this is one whole. This is a mixed number already. Okay, we can turn it around if you want, like this. So this is one whole. So we have 1 and 2 over 3, or 1 and 2/3. So we have converted from improper fraction to mixed numbers. Okay, and similarly, okay, if you want to convert from mixed numbers to improper fractions, say we have 5 over 3 or so. Okay, say we have 1 and 2 over 3. Okay, like this. This is a mixed number, 1 and 2 over 3. and we want to convert this into improper fractions. So we look at the fraction over here. The fraction over here is 2 over 3. 2 over 3 means the base fraction is thirds, okay, 1/3. So because the base fraction is 1/3, we divide the whole into thirds, okay, we divide it into thirds. Okay, because we want the fractions to be the same. So now we have all in thirds. Okay, so now we remove the 1/3, 2/3, 3/3, 4/3, 5/3. So 1 and 2/3 is 5 over 3. Okay, so 1 and 2 over 3 is equivalent to 5 over 3. So we have changed from mixed numbers to improper fractions. Okay, class? So this is using manipulatives. Huh? Okay, so let's continue a bit more, okay? Okay, so we're going to go back to equivalent fractions for a bit, yeah? So just now we saw that when you want to teach equivalent fractions, okay, we use the fraction wall, okay, or you can say fraction tiles, okay, or you can even, if you're using it in the form of a chart, then it's called a fraction chart, okay? Or the other way of teaching equivalent fraction is to use the area model. Okay? For example, you want to find out what is the equivalent fraction of 1/2. So you draw a rectangle. Okay, you draw a rectangle, divide it by 2, shade 1/2. So you know that this is 1/2. When they learn equivalent fractions, they already know how to represent fractions. Okay, so this is 1/2. Take a similar size rectangle, same size. Okay, so it's too much exactly the same size. And now you divide it into 1/2, shade the exact same area. So you want to find equivalent fractions for 1/2. Now you can divide it into 2 like this. Now the fraction representing the shaded area is 2 out of 4 parts. Therefore, 1/2 is equivalent to 2/4 because the shaded area is exactly the same size. Okay. Another example, okay, say you want 1/3, okay, so divide it into 3 parts and shade 1 part. Then you want to find an equivalent fractions for 1/3, okay, this is 1/3. You want to find equivalent fractions, you can divide it. Okay, so we divide it into 2. Okay. Okay, so we divide it into 2. So this will be okay, so if I divided it, okay, if I divided it, I divide here. Okay, if I divided it into 2, then it becomes 2 out of 6. So from here, we know that 1/3 is equals to 2 over 6. Okay, so we start with small examples, easy examples, and then we can teach them to find equivalent fractions as many as they want. Okay, say we start with 1/3. Okay, 1/2 like this. Okay, say we start with we have 1/2 here. Okay, so one side is shaded, this is 1/2. If we want to find equivalent fractions, we can divide this into 2. Now we have 4 parts. So we know that 1/2 is equivalent to 2 parts out of 4 parts because 2 parts shaded. We can further divide it. So now we have, whenever we divide, we must make sure that we divide into equivalent parts. Now we have 4 parts out of 8 parts. Okay, so it is 4 equivalent to 1/2 is equivalent to 4/8. We can divide further. Okay, so we have 16 parts in total, 8 shaded. So 1/2 is also equivalent to 8/6. So we can keep on dividing to show them that to find equivalent fractions for 1/2. Okay, so this is using the area model. Okay. Okay. The other model that we want to use to teach equivalent fractions is using the number line. Okay. Okay, say we wanted to find the equivalent fractions for 1/3. So on our number line, 1/3, this is improper fraction, so which means it's less than 1. So let's mark 1 first, okay? So this is 0 to 1. All our fractions are between 0 and 1 because they are proper fractions. Yeah? So 1/3 means 3 parts. So we divide this into 3 equal parts. So this is 1/3, this is 2/3. Okay, so our fraction is 1/3. Okay, so if we wanted to find an equivalent fraction for 1/3, this same number line, the same length, we can divide it into further parts. Say we want to divide this first part into another 2 equal parts, another 2 equal parts here. Now the fraction is, there are 6 equal parts. So this fraction now is 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, which is 1. Okay, and if we wanted to divide it further, okay, I want to divide some more, one more equal part here. Okay, so now this fraction will be, how many equal parts are there now? 12 equal parts. So each part will be 1/12, 2/12, 3/12, 3/12, and this is 4/12. Okay, so from this diagram here, we can say that 1/3 is equivalent to 2/6 is equivalent to 4/12. Okay, so once students know how to do this already, okay, once they know how to do this, when you've done many examples and they can see relationships like this, from here you teach them to come up with the algorithm, how to do it using algorithm. Okay, so how did they get 1/3 is equivalent to 2/6? Okay, so we can also write this as 1/3 is equivalent to 3 times 2, 1 times 2, and this is equivalent to 2/6. And 1/3 is equivalent to 3 times 4, 1 times 4, which is 4/12. Okay, so here you times the numerator and the denominator with the same number. Here we times the numerator and the denominator with the same number. Okay, so from this activity and from the earlier area activity also, we can show them like this. From here, we can help the students to realize that in order to find equivalent fractions, you only need to multiply the numerator and the denominator with the same number. So if you want to find the equivalent fractions for 4/5, you need to times with any same number. Okay, 4/5 times 3 times 3. So this is 12/15. These two are equivalent. Okay, so don't rush and teach them algorithm first. Okay, we need to teach them conceptually. When you do this, you are teaching them conceptually. Okay, when we do this, we are teaching them procedurally. Okay, we don't want to teach them procedurally first. We want to teach them conceptually first, and then you must teach procedurally. Okay, so this is equivalent fractions. Okay, now we go on to comparison or comparing of fractions. So say we had two fractions, 1/2 and 5/8. Okay, 5/8. We want to compare which is bigger. So you can also use an area model to compare this. Okay, so we should always start with concrete. We start with concrete and then we move on to area model because we're drawing it, so it can be pictorial. So we can use pictorial. So from concrete, we're moving to pictorial. Okay, so use the same size area. So this is 1/2, shade 1/2. And then using the same size rectangle, okay, we must emphasize that, okay? Same size rectangle, now we want to divide into 8 parts, okay? So 1, okay? Using the same size rectangle. Okay, so we shade 5 parts. Okay, so from here, because the rectangle is the same size, we can see clearly that 5/8 is greater than 1/2. Okay, so this is using the area model. Okay, another example, 3/4 and 5/6. Okay, to know which is bigger, also we use our area model. We have 3/4, which means we have to do 4 parts. So this is 3/4 here. Okay, and this is 5/6. Okay, same. Uh, so 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. Say lah, okay, my drawing's not very good. So 5/6. So I have 1, 2, 3, 4, 5, 2. So I'm going to shade 5 parts. But you see the part that we shaded, they are very close together. So it's difficult for us to compare. So what we can do is this 3/4, we divide it into a further 6 parts here. 1, 2, 3, 1, 2, 3, and the 5/6 we divide it into another 4 parts here. Okay, so altogether we have 24 parts in both the diagrams. Okay, so here we have 6 times 3 is 18, and here we have 5 times 4 is 20. Okay, so from here we know that, okay, so we can see that 5/6 is equals to 20/24, and 3/4 is equals to 18/24. Okay, so therefore, since 20/24 is greater than 18/24, therefore 5/6 is greater than 3/4. Okay, so here we have used the concept of equivalent fractions. Okay, we've used the concept of equivalent fractions to compare fractions using the area model. Okay, okay. If we want to convert improper fractions to mixed numbers, okay, and vice versa. Okay, okay, say first example, say you're given a improper fraction, you want to change this to mixed numbers, okay? So first represent 7 over 3. What is 7 over 3 to you? So 7 over 3 is one part here, two parts, 3. So this is 4 over 3, 5 over 3, 6 over 3, 7 over 3, okay? So each one is 1/3, okay? So we have 7 over 3. This is what 7 over 3 means. Now we want to change this to mixed numbers, which means we take 1 here, okay? Take this one, put it here. Take this one, put it here. And this one, put it here. So we have one whole already. So we have another one here. Take this, put it here. Take this, put it here. Take this and put it here. We have another whole. Finally, the last one, we cannot fit into any hole, so it's left behind. So here we have 3 parts out of 3, 3 parts out of 3, and 1 part out of 3, okay? So we know that 3 over 3 is 1, this is 1, 1/3, okay? So this will give us 2 and 1/3. Therefore, 7 over 3 is equals to 2 and 1/3, okay? So this is how we change from conceptually, okay? How we change from improper fractions to mixed numbers conceptually, okay? So after we do this, we have to teach them the algorithm. Normally, when you're given the algorithm, how do we change this to mixed numbers? Straight away, we divide like this, right? 3 times 2, 6, 1. So this is 1, 2. So this is 2, 1 over 3, okay? So this equals to 2, 1 over 3. This is the algorithm that we usually do in school, okay? But before you do this, you should actually do this 7 over 3. We know that this is thirds, okay? So how many thirds are there? We have 3, we have 7 thirds, okay? So we can write it as 3 over 3 and 3 over 3. This is already 6 thirds plus another 1 over 3, which is 1 plus 1 over 3, which is 2, 1 over 3. This algorithm has to be taught first. Here you are teaching conceptually. Here you're just teaching them proceed, just follow the division procedure, and then you take this answer right here, write this, okay? This is just procedure, follow rules. Here we are teaching conceptually, okay? So we should always teach conceptually first before we teach procedurally, okay? Give me 1 minute, class. Finish up. Okay, sorry, because it's blackout here, I can't see anything. Okay, so that is changing improper fractions to mixed numbers, okay? Okay, next we're going to look at how to convert mixed numbers to improper fractions. Okay, say we had 2 1 over 4 and we want to convert this to improper fraction. So we know that 2 1 over 4, it actually means 2 plus 1 over 4. 2 is a whole number plus 1 over 4. So let's represent 2 1 over 4 first. So we have 2 wholes here, okay? And we have 1 over 4. So this is 2 1 over 4. And now we want to change this to improper fractions. So we know that the base fraction is 1 over 4. So we want to change everything or divide everything into 4 parts, okay? Okay, so now we have 1 1 over 4, 2 1 over 4, 3 1 over 4, 4 1 over 4, 5 1 over 4, 6 1 over 4, 7 1 over 4, 8 1 over 4, 9 1 over 4. So 2 1 over 4 is equals to 9 over fourths, okay? So this is to teach them conceptually, okay? So from here, we also should relate that 2 1/4 is actually 1 plus 1 plus 1/4, and 1 is actually, because the base fraction is 4, so 1 is actually 4/4 plus 4/4 plus 1/4, which is 9/4. We should teach them like this first because they can relate it straight away to the diagram, okay? So once they have got this already, and then only we teach them how to do it using the shortcut method. Normally what we teach them is this one, 2 times 4 plus the answer, okay? 2 times 4 plus 1/4. This is the way we teach them to do algorithmically, okay? But this is, if you just teach them this alone, they forget after some time. They don't know whether you times 2 times 4 or whether it's 2 times 1. They're not sure, okay? So that's why we always teach them conceptually first before teaching them algorithms. Okay? Okay, I have only one more short question only, okay? Let's do ordering of fractions. Ordering and comparing and ordering of fractions, okay? Okay, supposing you had two fractions, say you had 2/3 and 1/2, which is greater? So if you want, one good strategy to use is using mathematical reasoning, okay? We can use mathematical reasoning to just work out the answer without actually converting to equivalent fractions, okay? So you know that our fractions are less than 1, okay? So proper fractions are less than 1, so this is 0, 1, and this is half. You need to mark all these 0, 1, and half. So 2/3, is this greater than half or less than half? So the question that you must ask is this greater or less than half? 2/3, is it greater or less than half? What is half of 3? Half of 3 is 1.5. So 2 is more than 1.5, okay? So that means 2 is greater, 2/3 is greater than half. That means 2/3 is somewhere over here. This is 2/3. And half, you know, it's exactly here. So from this diagram, you know that 2/3 is greater than half, okay? So this is using mathematical reasoning, okay? So supposing you had another question like this, 1/8 and 3/5. 1/8 and 3/5, which is greater, okay? So use a number line. So use a number line, okay? Mark your 1, 0, and half, okay? Then is 1/8 greater than half? You know straight away that 1/8 is less than half. And you know it's only very small fraction, so it's very near to 0. So this is 1/8. 3/5, is it greater than half or less than half? Okay, half of 5 is 2.5. So 3 is bigger than 2.5. That means 3/5 is greater than half, but it's very close to half. So it's somewhere here. We just estimate, okay, 3/5. So from this diagram, we know straight away that 3/5 is greater than 1/2. Okay. Let's do a few more fractions. Say you had 4/5, 1/3. Okay. 6/8. And 3/7. Okay, so how do we arrange this in order? How do we order these fractions quickly? Okay, so let's draw our number line and put the halves here. Okay, so let's look at it one by one. 4/5, we know it's more than half already. Half is 2.5, and we know it's very close to 1. It's one part away from 1. So 4/5 is here. Okay. 1/3, less than 1 and close to 0. 1/3. Okay. 6/8, 6/8. Okay. 6/8 is definitely more than half. Definitely more than half. But where is it here? Is it after 4/5 or is it before 4/5? Is it greater than 4/5 or less than 4/5? Is it here or is it behind?
Less than.
Less than. Why less than? Okay, I think it's because it's 2 parts away from 1, and this is 1 part away from 1. And then we have the last fraction, 3/7. Half of 7 is 3.5. So we know that 3/7 is less than half, but it's close to half. Okay, so it's less than half, but close to half, 3/7. So straight away we have ordered this. This will be 1/3, 3/7, 6/8, 4/5. Okay, without using any calculations, just by using mathematical reasoning, we have ordered this. Okay, so this number line, okay, this number line, and marking 0, half and 1 and deciding where the fraction lies. Is it above half or is it below half? Is it near to 0 or is it near to 1? With that reasoning, we can compare fractions easily. Okay, we can compare and order fractions easily. Okay, class?